Forrest Breyfogle III. Implementing Six Sigma. Smarter solutions using statistical methods. Whatever your business, you probably recognize this pattern. You spend your day putting out fires, solving urgent problems, and responding to the crisis of the moment. You work hard, you make adjustments, and you keep things moving. Yet the same types of issues seem to crop up again and again. This constant cycle of reactive problem-solving can be exhausting, and it often feels like you're running in place, never truly getting ahead. This Blink provides a blueprint for fixing the system. You'll get the practical playbook for implementation, equipping you with the plans, metrics, and checklists needed to build a quality program from the ground up. What's more, you'll gain the foresight to avoid common pitfalls and develop the capability to move from simply advocating for change to actually engineering it. Sounds good? Let's get into it. From firefighting to fire prevention. Does this sound familiar? A problem flares up and a team scrambles to put out the fire. They work hard, fix the immediate issue, and everyone breathes a sigh of relief, until the next fire erupts somewhere else. This cycle of reactive firefighting is exhausting, and it rarely leads to lasting improvement. To truly get ahead, you need to stop focusing on the smoke and start addressing the systemic issues that cause the fires. This requires a fundamental shift from viewing your organization as separate functions to seeing it as a single interconnected system. So how do you make this shift? Well, it starts by changing how you measure success. Many businesses focus on the cost of poor quality, calculating the expense of fixing defects after they occur. But there's a more powerful approach, measuring the cost of doing nothing different. This forces you to quantify the hidden expense of inefficiency that is often just accepted as the cost of doing business. The iceberg of these hidden costs is often far bigger than the visible tip of direct failures. By calculating the true cost of maintaining the status quo, you create powerful data-driven urgency for change. Now, armed with this financial perspective, you're ready to build a smarter measurement system. This is where the Integrated Enterprise Excellence, or IEE, framework comes in. Picture viewing your organization from different altitudes. The satellite-level view gives you the big picture, tracking high-level business metrics like profitability, market share, or return on investment. And here's the key. These are tracked over long periods, not just quarter to quarter. Why? Because it helps you see the true, long-term performance of your business system and keeps you from overreacting to short-term fluctuations. From this bird's-eye perspective, you descend to what we call the 30,000-foot level. This focuses on the key operational processes that actually drive those satellite metrics. Here, you're tracking your value streams, production cycle time, customer wait time, order-to-delivery time. Using control charts, you can see which processes are stable and predictable, and which ones are failing to meet the performance levels you need. And here's where it gets interesting. This cascading measurement system creates incredible momentum for improvement. The data itself identifies where real problems lie. So when a 30,000-foot level metric underperforms, the process owner has concrete data to request a Six Sigma project, and they know it's already aligned with company strategy. You've created an environment where everyone's working on the right things for the right reasons. This foundation is your starting point. But to really act on these insights, you've got to make sure the data you're collecting at ground level is telling you the truth. Why traditional metrics fail and what to do about it. This philosophy of seeing your business as a complete system is pointless if the very tools you use to see it are flawed. To get ahead, you must first challenge the metrics you use to measure performance, because what you measure determines how you react. Picture a typical factory floor. Say a certain measurement comes in at 78.2, just outside the upper specification limit of 78. A manager yells, "Joe, go fix the problem." Joe makes an adjustment, and the next few readings are fine. Hours later, a reading of 71.8 comes in, below the lower spec of 72. Now it's, "Mary, you fix it." This continues all day. But here's the thing, when you plot all the data over time, you see that nothing has actually changed. The process is stable, producing a consistent pattern of variation. The managers were reacting to the inherent noise of the system, something called common cause variation. By constantly tweaking the process in response to this noise, they were likely making things worse. So how do you break this cycle? You've got to learn to separate signal from noise. The IEE framework accomplishes this with the 30,000-foot level control chart. Instead of taking many samples in a short period, you use infrequent sampling, maybe one random sample per day or week. This approach is powerful because the longer time between samples naturally captures the routine, day-to-day noise. Different operators, batches of material, within the control limits. But these control limits are calculated from the process's own variability, not from arbitrary specification targets. This creates a high-level view of your process's true performance. When a data point falls outside these wide limits, you know you've got a genuine signal, a special cause, that warrants investigation. And when the process is stable but still not meeting customer needs, you know you've got a systemic problem requiring improvement of the entire process. This smarter way of measuring exposes deep flaws in accepted industry practices. Take acceptable quality level, or AQL, a common method for inspecting batches. An AQL of 1% sounds reassuring, right? But the operating curve often reveals that a lot would have to be 3 or 4% defective to even have a 50-50 chance of being rejected. It's a system providing false security while consistently allowing poor quality to pass. The DMAIC Roadmap. So you now have a reliable baseline. Next up, you need a structured method for acting on what you see. That method is the DMAIC Roadmap, a 5-stage process that provides the engine for systematic improvement. Rather than rigid rules, think of DMAIC as a logical narrative that guides a team from a vaguely defined problem to a controlled, sustainable solution. It transforms the often chaotic art of problem-solving into a replicable science. Your journey begins when you define the destination. In this first phase, you create a project charter that does more than just state a problem. It explicitly links that problem to a high-level business goal. This charter acts as your map, ensuring the team, management, and other stakeholders are all aligned on the project's purpose and scope from the very beginning. Then, the measure phase establishes your starting point. Remember that 30,000-foot level control chart we talked about? Here's where you use it to create a stable, trustworthy picture of your process's current reality before you attempt to change it. You'll map the process, gather the wisdom of the organization through cause and effect diagrams, and, this is critical, conduct a measurement systems analysis to ensure the data you're collecting is accurate. With a clear starting point and a list of potential causes, you enter the analyze phase, a period of passive investigation. Here, your goal is to sift through all the potential causes you've identified and find the vital few that are truly driving your process's performance. You're not changing anything yet. You're simply using graphical tools and statistical tests to analyze existing data. This is where you separate fact from opinion, allowing you to move forward with the confidence that you're focused on true root causes, not just the most obvious symptoms. This leads directly to the improve phase, where you shift from passive analysis to proactive testing. This is where the real breakthroughs happen. You'll use powerful tools like design of experiments to systematically test different settings for those vital few inputs you just identified, helping you find the optimal combination that will improve performance and reduce variability. We'll explore this more in the next section. Once the best solution has been tested and verified, the final control phase ensures the gains are permanent. This is achieved not just by writing a new procedure, but by implementing robust controls. Often, you'll shift your monitoring from the final output, a lagging indicator, to the key process inputs themselves, which are leading indicators. By controlling the inputs at what we call the 50-foot level, you prevent the process from ever drifting back to its old ways, locking in the improvements long after the project team moves on. While every stage of this journey matters, it's often in the improve phase where the most transformative discoveries are made, thanks to the power of structured, proactive experimentation. Let's explore why this phase is so revolutionary. Unlocking potential with DOE. To truly create a breakthrough with the DMAIC roadmap, you have to intentionally interfere with your process to see what it's capable of. The single most powerful tool for this: Design of Experiments, or DOE. It's a method that fundamentally changes how you solve problems, moving you from inefficient guesswork to structured, rapid learning. To understand its power, consider the traditional way most people try to fix things, one factor at a time. Picture an engineer trying to improve a process who suspects that both bake temperature and a chemical additive are important. First, they hold the temperature constant and increase the additive, but the result gets worse, so they return the additive to its original level and increase the temperature. This time, the result improves slightly. The logical conclusion seems to be that high temperature and low additive percentage is the best combination. But here's the problem. This one-at-a-time approach feels methodical, but it's dangerously flawed. It can completely miss the most important discoveries. What the engineer didn't test was the combination of high temperature and high additive percentage. Had they done so, they might have found a result that was dramatically better than any of the others. Why? Because factors can interact. The effect of temperature might depend entirely on the level of the additive. One-at-a-time testing is blind to these critical interactions. Design of Experiments solves this problem by testing multiple factors simultaneously in a structured way. Instead of dozens of individual tests, a well-designed experiment can evaluate many variables, perhaps 7 or more, in as few as 8 to 16 trials. It's like a highly efficient matrix in which each trial represents a unique combination of factor settings. It not only saves tremendous time and resources, but it's also the only way to uncover those crucial interactions between variables that drive the most significant improvements. By analyzing the results collectively, you can see the effect of each individual factor and, more importantly, how they work together to shape the final outcome. And this approach isn't just for manufacturing. Its principles are universal. Imagine a school district wanting to reduce student absenteeism. Instead of trying one initiative after another, they could use a DOE. The factors might be day of the week, say comparing Mondays to Fridays, whether to implement parent callbacks, and which schools to test in, comparing one with high attendance to one with low attendance. By testing different combinations across groups of students, the district might discover a powerful interaction. Perhaps the callback program is wildly effective at reducing Friday absenteeism, but has almost no effect on Mondays. This insight would be nearly impossible to find any other way. It allows you to target your resources with surgical precision, applying the right solution where it will have the greatest impact. Mastering a tool this powerful is a major step in your journey, but the ultimate goal is embedding this kind of structured thinking into your organization's very culture, creating a system that learns, adapts, and improves continuously. Creating the integrated learning organization. Building a system in which structured thinking becomes second nature is where the real magic happens. You've mastered breakthrough tools like Design of Experiments, but now comes the next chapter, weaving the IE philosophy into the very fabric of your company, creating a single, cohesive strategy for continuous improvement that aligns and enhances all your business initiatives. So what does this integrated system actually do? Well, it makes everything you do smarter. Take the way it seamlessly blends Six Sigma with lean principles. Six Sigma reduces variation and eliminates defects, right? And lean improves process flow by eliminating waste. Things like excess inventory, unnecessary transportation, or waiting time. The IEE framework provides the overarching measurement system that tells you which tool to reach for. Say your 30,000-foot level chart shows that your process has low variation but runs too slowly. That's a clear signal to apply lean tools to improve flow. Conversely, if a process is fast but inconsistent, creating unpredictable results, that's a classic problem of variation, signaling the need for the structured DMAIC journey to analyze the root causes and proactive tools like Design of Experiments to engineer a more reliable outcome. Now, here's where it gets interesting. As your organization grows into this way of thinking, your focus naturally shifts from fixing existing problems to preventing them from ever occurring. This is where Design for Six Sigma, or DFSS, comes into play. Remember how we talked about DMAIC improving existing processes? Well, DFSS uses those same data-driven principles to design new products and services that are high quality and defect-free from the get-go. It's a proactive approach, using tools like DOE to create designs that shrug off variations in manufacturing or use. By applying these principles up front, you move from a culture of correction to one of perfection, building systems designed for excellence from their inception. What you're really creating here is what's been called a learning organization, a business that overcomes common institutional learning disabilities by using data to constantly challenge assumptions and recognize new opportunities. And this represents a cultural transformation. Leaders stop managing by reacting to numbers and start leading by improving the system. The central question shifts from, "Why didn't you hit your target?" to, "What is the status of the improvement project for that process?" Think about how different that feels. Instead of the monthly blame game, where managers scramble to explain why they missed their numbers, you have productive conversations about system improvements. Instead of heroic firefighting being rewarded, prevention becomes the hero's journey. In this Blink to Implementing Six Sigma by Forrest Breyfogle III, you've learned that the most effective way to improve any organization is to stop the exhausting cycle of daily firefighting and instead adopt an integrated system that uses clear, high-level metrics to drive structured projects, solve problems at their roots, and create a culture of continuous proactive improvement. This transformation begins by replacing flawed, traditional metrics with a high-level view that separates real signals from background noise. With this clarity, you can use a structured roadmap to analyze problems and then apply proactive tools like design of experiments to find optimal, lasting solutions. This approach moves beyond completing individual projects. It integrates with other methodologies like Lean and Design for Six Sigma to create a true learning organization, one that consistently delivers better results for your customers and your bottom line. Okay, that's it for this Blink. We hope you enjoyed it. If you can, please take the time to leave us a rating. We always appreciate your feedback. See you in the next Blink.